Hello! Library methods in Java continued. In the previous video we saw simple one up to square root. Now comes a similar one called CBRT. A little bit of phonetic help we can take and it should give us the hint of cube root. And yes, CBRT is the abbreviation of cube root. Now, if I look at the example, there is one variable that I have to supply and the compiler, after compiling it, the method's return will be the cube root of that variable. So if I supply 125, I'm expected to get 5. Now come to the program example. And here is the program example in front of you. See, what is it saying? I have used both the methods, which is math.square-root and math.cube-root, SQRT and CBRT. Variables are n1 with 900, n2 as 125. What is the first application variable? Double SN1. SN1 is storing the square root of n1 and Cn2 is storing the cube root of n2. Look into the output screen. In the output screen, you will see that the variables square root of 900 and the cube root of 125 is getting calculated and printed. Okay. Now, you can change the number when you run the program on your own. You're most welcome to change the number and test it all by yourself. Okay. Coming up is one more example of another library function. The next one is CEIL. CEIL comes from ceiling. Ceiling means once look at your own room. You will find there is a floor and there is a ceiling. That ceiling actually in programming, Java programming, has been used to return the nearest next integer value. That means the integer which is close to it in the higher value. So, if I call the variable as 53.2, we are used to do by from our maths as what is the rounded value. The rounded value with 0.5 takes it to the higher and less than 0.5 brings it to the lower. But ceiling, even if it is little bit of anything, takes to the higher. And there is another called floor. Floor, whatever be the value, brings it to the lower. So this one's program example is best to be seen. And here is the example of program. Look at the program. It says there are two variables and they are of data type double. Otherwise, the fraction part will not go in integer. The integer application is in way that the return is the nearest integer and that also in the form of a double. So 0.0 will appear. Now 6.3. What is the ceiling value? This means which is the next integer which is larger, nearest larger than 6.3. You climb upwards, reach 7 and say that yes, 7 is the next largest integer. Okay. And if you look at 4.8 and then 4.8 says if you want to take it down to the floor, you climb downwards and you get the nearest integer, then you will get 4, right? Now, with this, if I show you another interesting example, and it is here. Look at this example and can you make a guess? What do you think the answer will come as? The ceiling of 24.001. That means even if it is little bit more, then also it is more. Then what is the next integer which is higher than it? Let us see. And parallelly also look at 24.99. It is nearly 25. It's just going to be 25. If I look at that, what is the value expected from the floor of that? Because it has not become 25. Okay. Let me run this and show you the output. Can you see 24.001 is also going up to 25 for the ceiling, and 24.99, which is so high, that is coming down to 24. But if I convert that 001 back to 24 and want the ceiling of 24, 24 is itself the next higher integer. You don't go to the next if you are already an integer. Similarly, for 34, it is not coming down to 33 for the floor. 34's floor is 34. 24's ceiling is 24. Even 24's floor is 24 and 34's ceiling is 34. Now this is going to you for your round of practice. Try it once. Okay.